All right. Hey, everyone. Welcome on in. Happy Saturday. We're going to be building our next lesson in machine learning introduction. We're going to be doing some linear regression, which sounds pretty basic, but it turns out is the most important part of the AI because we do pretty much all of the feed forward with the prediction, the gradients, calculating the gradients. The only thing that takes it from this, hey, Quick Fix, good to see you. First, number one, welcome on in. Hey, you made it home. I saw you had made it home on Discord. You said, hey, you're welcome. Are you done with vacation now? Is it over? That's crazy. That was an amazing vacation, long vacation. I haven't done that myself for a long time. I don't remember. Yep, nice. All right, good to hear it. We're going to continue our introduction to machine learning today. And then, let's see, 1 week? It's really, that was only 1 week? Okay, well, that's a good vacation. That's a good, ordinary vacation. Yeah, I've seen people take 2 to 4 week vacations. And I'm like, whoa, hey, that's a good vacation right there. That's like a long vacation. So yeah, I'm going to be pretty excited to see how far we get here in our machine learning today, because there's quite a bit, and this one's a little bit complex. It will be a little bit more complex than what we've been doing, because we've been initializing. We've only been initializing variables using different NumPy functions. And so this time around, we're going to be doing it's a little more intense. Like it went from medium, slow, pretty easy, casual, to now we're taking up to level 5, right? So it's like a big jump. It's going to be a big jump. All right, so let's see here. We're going to do lesson 6. We're going to say this is, what do we want to call this? I guess linear regression. Regression. That's what we should call this, yeah? SION, yeah, right there. Linear regression. Lesson number 6, right there. Okay. And which is similar to what we did with our solver. As you can see here, we did our solver yesterday. That was like the easy option. Now we're going to actually show you what's inside the solver, essentially. We're going to build our own. And this is very similar to building your very own AI model from full deep learning model. It's not far off from that. So let's see here. Let's see. Close that. Yes. Close this, and then let's see, is there other Python REPL stuff that I could do here? Let me get this set up really quick. Let's see, auto reload and then load. Is there another one of these? Reload 2. Okay, I don't know, I don't remember specifically what those were, but they did make it so that way I can import another lesson here. So let's get this going here. Quick Fix, thanks for saying hi. Thanks for clicking the hi button. All right, where are we right now? We need to do lesson 6. All right, Py lesson 06.py. How many days do you think will be wasted? Sorry, I mean used for this project. Do you want to get onto the YouTube, the building YouTube from scratch? Is that what you want to jump onto? I think that's what you're referring to. So this, let's see here. So this is much. Yes. All right. I figured. Probably another couple days, maybe. And then on Monday we have a guest speaker. So that will be talking about AI agents, things like that. And so maybe Tuesday. Does it sound like good? Is that too long from now? What do you think? Tuesday? Does about Tuesday sound good? Let's see here. And then we will finish our introduction to machine learning. So this is going to be import NumPy as NumPy, or as NP. Here we go. NP. All right, NumPy as NP. It's okay. Is it? All right. All right. Sounds good. We could always take a break from machine learning and jump in. It's up to us. Whatever we want to do. Whatever we are interested in doing. Okay, so let's see here, gradients. So I've got my notes over here on the side of what I want to do. So basically we're going to be doing linear regression today. Let me close this right there. Import lesson 06. Can I do that? Oh wait, I never saved it yet. There we go, lesson 6. Let's try it now. There we go. All right. Continue. Oh wait, hold on. Oh, today. What do you think? Oh wait, thank you for the hearts, appreciate it. What do you think of my humor? Today? Wait, what do you mean? Like on Discord? I mean, some of it's questionable. But some of it's actually funny. Like if you, the things that you share. I'm like, wait, because you mess with my YouTube algorithm when I watch those things. It changes things up, you know? In stream? Oh, I mean, it's good. You're fine. Wait, how many days do you think? Oh, yeah. No, yeah. I know what you're saying. I understand. You're joking. I know. Okay. Where are we here? All right, so let's create. How do I want to do this? We could do this a couple different ways. We could make it like a model. Hey, how's it going there? Hey, Aris, Scott, welcome on in. Happy Saturday. Good to have you here. Hey, yo, welcome on in. We are building machine learning from scratch is what we're doing. We're doing introduction to machine learning. Introduction to machine learning. That's what we're doing here. All right. How's it going there? Hey, how's it going there? Welcome on in, you guys. What are we creating? Yeah, that's what we're creating. Don't forget to like. Oh, thank you. Yeah. Appreciate it. Hey, Squirrel Sniper, good to see you from across the pond. Ruthik, hey, how's it going? You too. Hey, all right. I got the GGs right away. Thank you very much. Please pin your comment. Which one? Which comment? Oh, the don't forget the like comment. Okay. 1 second. Pin. There you go. All right, you're pinned. You're pinned now. Hey, Ara Scott, thank you very much for the GG. My gratitudes to you. You like my 12-second circular buffer then? I sure did. Good to see you, Squirrel Sniper. Ruthik, good to see you as well. Sergio, machine learning. Yeah, that's what we're doing today. We're doing introduction machine learning. Hey, we got another one. AR Scott, thank you very much for the flower, you guys. So wonderful for you. I appreciate it. Where did I learn to code? I learned to code when I was 11. I had a CD-ROM that had the Borland C++ compiler on it and a book called Sam's Teach Yourself C++ in 24 Hours. And I read through that book and I didn't understand very much of it. And it was a mistake to start with C++. I eventually learned other languages. C++ was my first language. C++ at 11. At 11 years old is when I just started. Thank you. Are we going to break our record? Oh, wait, no, probably not. That was yesterday. That was a huge record. I don't think we'll do that for a little while. That was like 30 minutes of continuous donations. I was not expecting that. R. Scott, thank you again. I appreciate it. Thank you very much for the flower and for the GGs. Oh, hey, I was going there. Seraphim. Hey, Seraphim Official. Welcome on in. You put 48K on the L1 is your best idea yet. 48 kilobytes on L1 cache. All right, Squirrel Sniper. Gone through your company profile. You're providing WebRTC services. Yeah, yes. So we provide the ICE candidate exchange, right? So you can use WebRTC without having to have like extra servers. So you can do ICE candidate exchanges, things like that. You started Python at 10. Yeah, quick fix. You win. You win. All right. GCA, good to see you. Okay, so we're going to do, this is going to be called linear regression. However, it's pretty close to what full AI is. This is like a full AI model. Very, very close to it. We're not far off. Not far off on that. So let's see. I've got my notes over here. We need to do a couple of things. I'm trying to think about how I want to go about this. I think we could create a class so we could have I'm just not sure how I want to show it to you guys. Because we need to calculate gradients. We need to have a predict model, which is really easy. And we could just have weights and biases. So I think doing a class would make sense. Class regression. How about this? Linear, we'll call it linear regression. And then we'll say def init. And then we'll have our, what do we want? We don't really need to say anything in here, I don't think, other than like your inputs and output sizes. So hey, how's it going there? Matt Hindenbrock. Hey, thank you for the targets. Good to see you. Welcome on in. Oh, okay. So you're working on software developer intern. How can start a startup? You just start the company. That's what you do. You start building technology. You just start building your tech, and then you need to release the tech, and you need to start attracting users. It's really that simple. It's not that complicated. Do you have classes from basics? Yes. We just started the basics, so this is what we've done so far, you guys. So if you're curious about this, where we've been, this is what we've done so far. We did these courses yesterday, creating tensors, using tensors with math, right? Indexing, slicing, aggregations, linear algebra, dot product. And now we're gonna do linear regression, which takes it up to another level. Hey, Ruchit, welcome on in. Mathine. Oh, okay. Mathine, there we go. Excellent. All right. Hey, Frosty, how's it going? What are the prerequisites? Most, you know what? Not too much prerequisites, I would say. Because this was really simple stuff, right? Really simple. Here, I'll show you. We'll show you here real quick. 1 second. Let me delete these things. We'll save that. We'll open up lesson 1, right? Lesson 1, creating a vector, right? Creating matrix. These things are really simple, you guys. They're super simple. Hey, Mark Lemon, I've been great. Good to see you. Welcome on in. Can you please lower background music? Oh, sure. Yeah, absolutely. In fact, we will jump to the next song here. Let's see if we can do this. How about that? Is that better? Okay. All right. Background music. All right, lowered. There you guys. Do you have classes from basics? Yes, that's what we did. Okay. Good to have you guys here. Oh, Frosty. The entry-level job scenario for someone on an F1 student visa. I actually don't know. I don't know. I'm not familiar with that scenario. I don't know specifically. I'll see here. So this is where we've been so far, creating very simple things. So it's not that challenging. So if you want, the past 2 streams, just about 3 hours worth of streams, we covered the basics. And now we're gonna go into a little bit more of a hard mode here. A little bit more of a hard mode in lesson 6 with linear regression, which is it's basically machine learning at this point, right? This is basically machine learning. This is, in fact, is exactly what machine learning is. And it's not deep learning though, because we'll only be using 1 layer. Just 1 layer in this case. All right. So, not specifically developer intern, how can I start a startup? Yeah, okay. So if I didn't answer your question fully, just ask it again or let me know if you have something else that you would like to learn, because I answered it pretty quick because I'm trying to get into the course here. So we cover this for you guys. So I'm going to create thank you for the hearts, appreciate it. Good to have you guys here. All right. Can you check Discord? Wait, are you saying quick fix? Are you talking to me? Let me see here. You created a deterministic inline dual engine wrapper. That's an edge gateway interface to... Oh, ooh. Hey. Squirrel Sniper has the knowledge. Squirrel Sniper uses very advanced words. Squirrel Sniper has the experience. Okay. So let's go back into our lesson 6 here, you guys. So we're going to do some linear regression. Let's see here. Save. And we're going to say self.weights. WEIGHCS is gonna. We need to initialize our weights here. What do we want to make these? Let me think about how to do that really quick. Man, right here. Oh, interesting. All right, check your message. All right, real quick, I'll check it. All right, where are you? Wait, I don't see your message. Where'd you put it? Where did you put it? All right, I actually don't see it. It's not there. It's not there, quick fix. Where'd you put it? Okay, here we go. All right. Group project. Oh, all right, 1 second. Where real-time group project? Okay, here we go. Oh, should we add live streams? Oh, that's gonna be tough, but we could do it. Okay, so I voted. There you go. Don't forget yeah, exactly. Okay, here we go. So let me think about this. I need to think about this for a second. Weights and biases. Let me see here. X and Y train, weights and bias. Train, really interesting. All right, so okay, here we go. Okay. So np dot 0. I like random. I don't like zeros. So can we see, how do we do this? Random. Sudo -f. Oh, hey, Nikki G, how's it going? Welcome on in. Happy Saturday. Good to have you here. All right. So let's see here. I think random.uniform, right? Uniform. Can we do that? Let me see here real quick. Import NumPy as NP. See, yes, NP as NP. There we go. NP.random. Right. And then .uniform is a function. Yep. And then we pass in what our dimensions are going to be. So we can say how many dimensions we're going to have there. How many do we want? Let's see what happens when I say 10. That's not quite what I was. Oh, that gives us a range, right? So I'm trying to remember the specific function. Then delete. Okay. Thanks, bud. Nikki G. Yeah, good to have you here. Okay. So I want to create a random array. 1, 2. Can we do that? No, that's, how about 1, 4? What does that look like? 9. What if we put this in a tuple? Is that going to be different? 1 to 9. Let's see here. Random. I need to look this up. Let's look this up. All right. So let's do a quick help on this. Watch this. Help. There. Okay. Uniform. Low, high, size. Okay. Low and high. Method for random state instance. Low, high, and size, none. Draw samples. Okay, so if that's size, what does size need to be? Let's see here. Size is a tuple. Oh, there we go. Okay, watch this. All right, here we go. Perfect. Here we go. So we should be able to say low is be -2 and high will be +2. And it'll be a 10 by 10. We do that? Yeah, that's what I'm looking for. Okay, perfect. All right. Number of features, comma 1. So how does this compare here? All right. np.zeros, we'll say 10, comma 1, like that. Okay. So that'll be the weights. Got it. Okay. So we could go with this path as well. Perfect. Hey, Null Zero, welcome on in. Good to see you. Happy Saturday. Good to have you here. And SurfTube, thanks for saying hi. Good to see you. Welcome on in. Happy Saturday. This brings back to the engineering classes. Oh no, Super Chad. Well, that's what we're doing today. Bypassing RAM. All right. Let's see here. Oh, hey, Nikki G. Thank you for the subscription. You joined the right channel for software engineering. Today and tomorrow and yesterday, we are doing introduction to machine learning. We're doing some simple things, although today it's going to get a little bit more complicated. A little bit more tricky, and I'm going to try to set this up for you. Basically, we're going to build a linear regression engine today. We're going to build a linear regression engine. I would be very happy if we achieved that today. I think we could. It might bleed into tomorrow. The good news is it's pretty well contained. It's not a deep learning, it's just regular machine learning. So linear regression is what we're going to do here. So I'm deciding how I want to shape it. You believe me? All right, good to hear it. Yeah, thank you. Yo, Derek, good to see you at Machine Learning Time. Hey, and Kevin Francis, good to see you as well. What is linear regression? Hey, all right. Zergio, thank you for the membership again. All right, 3 months in a row. Check that out. Three months. That's fantastic. Quit, Sergio. All right, thank you. Hey, there's your dual engine protocol. All right. So we're doing linear. What is linear regression? It's essentially machine learning. It's where you give a model, a math model, input features, and then you expect output features. Right? So input and output. Usually it's going to be a binary classification where something is like a hot dog or not a hot dog, right? Something like that. It is a house or not a house. It is a cat or it's not a cat, right? That's binary classification. It could be a thing or not a thing. Often used in finance for fraud detection or predictions on whether they need to make avoid transactions of certain kinds. So that's what that is. Hey, all right. Thank you for saying you love the content. Good to hear it. First time joining live stream and excited for the machine learning content. All right. Yeah, looking forward to it. This is my favorite stuff right here. I love this. It's complex, it's tricky, it's somehow a little bit forgiving because you can get the algorithm slightly wrong and it will still work. That's how like frontier this is. It's really neat. It's really neat. So it's good to have you here as well. Thank you for joining in. All right, let's see 1 second. Let's check this out. Sahad? Is your name Sahad? As you say, Sahad? Okay. So I'm trying to figure out how I want to set this up. See here. So let's see. I want to say self.zeros. Now, do we want to go like this? Number of features is going to be the input. Okay, I got it. Okay. So let's say how many features we're going to have here. All right. So input features, and then like number of inputs, right? This is why that's important. We need to see exactly what that's for the number of features that we want. So let's do np.zeros. We'll just do zeros like this, zeros, and we'll say number of features, comma 1, like that. Okay. So this is regular linear regression. Why using class? We don't have to, Kevin. I just wanted to do it a certain way. I feel like it made sense to throw it into a class because we're going to hold data. And anytime we're going to hold data where we're going to have like self-weights and self-bias, right? I want to have this as a class. We don't need to do it. You're right. It's not necessary. It's absolutely not. Features. So how about this? Inputs and outputs. Outputs. And outputs can probably be 0. So we're just going to say number of inputs. So this is going to allow us to track different features. Features are essentially just numbers, right? And they're going to be representative. Is it a thing or is it not a thing? Like, what color is it, right? What color is it? How much does the house cost? Does the house live in a suburb or is it in the deep city? Is it urban or suburban, right? Those are the kinds of features, right? Those are features. So these are input features. Let's see, input features. Inputs equals features. Inputs equals the features of the whatever you're looking at. You're doing great, buddy. I'll definitely check back. All right, Nikki G, thank you. Thank you very much. Really love how it translates into complex architectures. Ooh, Sumit. That sounds interesting what you guys are talking about over there. Okay. So now we've got our weights and biases. You've heard of these things before. Probably, maybe, I don't know. And then let's see if we could do a def rep_rer, which is going to allow us to print this. So we're going to say self, we'll say return self.weights, comma self.bias. All right, let's see if we could do that. Okay, and then we're going to try to execute this here. So we're going to say linear regression model, although that looks like learning rate. So we'll say model equals linear regression, and our inputs will be, we'll say 10, for example. Okay. Then we'll print our model. Let's see what that looks like so far, yeah? See what it looks like right there? All right, then we can do this. We say lesson 06 dot model. Is it a thing? Here, I've got a better idea. We'll execute this directly. Python lesson 06. Okay. Gotta type Python correctly. Here we go. Python. There we go. All right. So we got a problem here. It shouldn't be a problem. Did I type this wrong over here? This looks good. This looks good to me. What is missing? What is it not like? Init. Def init. Did I type this right? This looks correct to me, right? Line 14, linear regression takes one positional argument, but 2 were given on the input. Oh, do I also do self here? Do I don't think so. Let's find out. Okay. Features not defined. Feature. Oh, right. Okay, there we go. Sorry. I just came back from doing a lot of Rust. And in Rust, it's a little bit different. It's, all right. It's just a smidge different, you guys. Hey, how's it going there? Gloomy traffic over there on Twitch. Good to see you. Welcome on in. Hello. Good to have you here. All right. So now we've got our inputs and our outputs. You know what would be nice if I switch the screen to be at the bottom here. Python lesson 6. Here we go. All right. Save. All right, so we go to zeros. We go to inputs, 1, bias, and weights. And I would like to print this out. Let's see us print our model. Oh, we want to do a string. All right, fine. Fine. str. Although if we did this, it's going to want... Let's just do this really quick. Let's see. All right. So that's pretty straightforward. Can we do a string like this? Is this something that we can do? I don't know if we could do that. I didn't think so. Okay. What if we can't add them together because that will do something different. So we'll just print out the weights for now. We'll just print out the weights for now. There we go. Which editor are you using? This is Vim. This is Vim right here, version 911752. That's the version right there. Naming's confusing right now. Sumit, let's see. Are you this? Yeah, that's fair. All right. So inputs equals number of inputs. Let's see it. Inputs equals number of input features. All right. So that's only one variable. And then weights, that's just what the industry calls it. That's what the industry calls it right there. They call it weights and biases, which is basically a bunch of numbers. That's all it is. Hey, Alex, good to see you. Welcome on in. Good to have you here. Happy Saturday. All right, let's keep going, you guys. So we've got our model. We're printing it out. Looks good. Happiness is there. Okay. So we need to define a few functions, right? We need to define a predict function. This one's the easy one. Predict, which is basically the forward, self, and then we need data here. We need data. You've never used Twitch before, so I'm analog. Oh, whoa, no way. Gloomy traffic. That's crazy. Hey, Peace Lord. Good to see you. Hello, hello, hello. Welcome on in. Happy Saturday. You learned machine learning. Oh, I sure did. That's what we're doing now. We're doing introduction to machine learning here. So right here, introduction to machine learning. That's today's plan right here. Happy Saturday. Nice. Good to have you here. Let's see if we can make our way. Let's make our way. All right. So how do we want to do this? Oh, Peace Lord. Thank you for the silver star. Appreciate it. That's really nice for you to do. Thank you so much. My gratitudes. We're very good day. It's a good day today. We're doing good today. All right, so we've got our predict function, we've got our self, and then we also want our inputs here, inputs. But the inputs are going to be different, right? What if we just call this features, features like that? Did this, rename the variables, so then we can have inputs here, and then we can throw those through the forward method, right? Throw those through the forward method. Seems like a good idea to me. A little bit of good idea right there. Thank you for the hundreds, guys. Yesterday was special for you. It was like a new record of amazingness. Hey, that was pretty fun. Yeah, I was talking about inputs. Oh, there we go. We can do input.dim instead. Input.dimensions. Well, with Python, you can, but then if you're going to do that, you'd have to say inputs, but that wouldn't work either way. You would have to do something extra. You have to do something extra. We could say dimensions, though, if you want. Dims. We could do dims. How about that? Inputs, number of input features, dims. Dims equals... There we go. So that way you get your dimensions. Yo, Benos, good to see you. Where are you streaming from? Seattle, Washington, United States. Hey, Riddick, also good to see you. Welcome on in. Hi, good to see you. Happy Saturday. I don't know, linear regression is done, but I tried to set the slope to the average of the slope between two consecutive points. Setting the y-intercept to x0, it yields quasi-good results. Oh, there you go. Looking good. Happy Saturday, Heretic. Thank you. That's pretty neat. That's pretty neat. I like that approach. Wait, dual engine, which is a Squirrel Sniper. Heard a 0.9 whole 9 consciousness model. It allows me to find missing data that's hidden within the input stream. All right, Squirrel Sniper. Okay, sounds good to me. I didn't know about that. Yo, machine learning, yes, that's what we're doing today. How can we train AI to analyze trends or support resistance in stock crypto charts? Oh, right. The best approach? You'd probably use a time series model. Use some time series model, right? A little bit of time series in there. You can do LSTM or like a transformer. A transformer is time series essentially for full self-attention. And then you can get, it's really how you want to paint the picture of the input model. A little bit of the paint picture and input model. Hey, how's it going there? Vine Dev. Sorry, can you explain about bias and weights? Yes. So these are parameters. They're numbers, as you can see here at the bottom of the screen. These are the weights right here. They're just going to be coefficients. They're like, if you're familiar with math, they're basically just numbers. So you've got coefficients. They're also called parameters. They're also called weights. They're basically kind of all the same thing. It's just going to be numbers that are going to be used to do multiplication with from input data. And then you adjust these numbers here. These numbers right here become adjusted. These numbers here. They adjust to up and down until they fit a set of data that you've trained it on. So that's the training part. That's the machine learning part. You put a bunch of data in, like a bunch of pictures. And then these numbers on the screen you see here, they become not zero, they become different numbers. And that's what we're going to try to show you today. We're going to show you how to change these numbers so they fit your model. Did you just go live? Yeah, I did about half an hour. I did 30 minutes ago. I sure did. Keras. Oh, yeah, Keras. I like that too. Let's see, train superset. So, NVIM Chad. You can use this approach as well for linear regression. So that's what we're currently going to build. We're going to build a simple linear regression model. It's going to be it. Thanks a lot. Yeah, absolutely. Vine Dev. You're absolutely welcome. Happy to have you guys here. Thank you. With Steven. Hello. How's it going there? Tugra. Good to see you. Happy Saturday. All right, you guys. Good to have you here. All right. So nowadays, new software engineers use machine learning without knowing the mechanisms behind the algorithm. They're not willing to learn the foundational concepts. Ah, right, I know. Well, we're going to go into it today. That's the plan for today. Let's see how far we get. Def predict line input variable needs to be changed to dims, right? Oh, wait, does it? Ruthik? So is this look okay? I think that looks okay. Hold on a second. Let's close this now. Get rid of this. There we go. Okay. Save, reload, def, pass. There we go. Okay. All right, we're back. Excellent, you guys. Thanks a lot. Good to have you here. When will you explain backpropagation? Oh, Alex. Okay. So we're going to do a little bit of backpropagation. A little bit today, sort of. Tugra, hello. All right. Cyber Jake, thank you for saying hello. Good to have you here, Cyber. Whoa, we've got multiple Cybers here, you guys. Your enthusiasm's most yeah, you're the most enthusiastic AI I've ever seen. Hey, Cyber, thank you. Good to have you here. We're a real human. We're a real human from Earth. Real human. Real ordinary human from Earth, you guys. Why your YouTube live is vertical? Because it's because that's how we have it. We got YouTube vertical. And then if you want, we've also got our horizontal over here on Twitch. If you want the horizontal. So that's how I split them up. I split them up like that. Most exciting engineer. Thank you, Sergio. Appreciate you. Thank you very much. All right. So let's keep going, you guys. Let's keep going. Yeah, so for those of you who are new here, thank you for joining in. My name is Stephen Blum. I'm the CTO at PubNub, co-founder. We raised a lot of money. We have Series E. We have over 1 billion devices on my network, right? Mobile phones. So if you've heard of any of these companies here, they use my communication bus that I invented. I've got patents for. I've got a lot of patents. Many patents, you guys. And they use us for, healthcare, telemedicine, fintech, stock quote updates, things like that, call centers for chat, communication, on-demand delivery, food orders, things like that. gaming, my favorite one though is multiplayer gaming. I like that. So if you've played any games, then that's where my technology is. And you've probably used it. Are you going to have a second session today like we did yesterday? Maybe, Cyber Jake, maybe. We'll see. Maybe. What's the pub Substack stack? Oh, hey, Ruthie. Thank you for following over there on Twitch. Good to have you here. You joined the right channel for software engineering. The pub Substack stack is C and Rust. C and Rust, that's the stack. Pub Substack is custom Rust and C code. That's where we're at. Stephen, please tell us more about this bus of yours. Oh, the bus! Well, if you guys are interested, so this is a thing that's, you can see my patent. It is open and available. You can scan down to here. Let's see here. Distributed transmission of message in a communication network for selective no, that's selective replication. You don't want to care about that one. Method for system for detecting latency. Not that one. We've got multiple patents here. Let me see if I can find them. Let's scroll. Real-time distribution of messages via network with multi-regional application hosted in. Here we go. This is the one you want. This is the one you want. So if you want to hear about my technology, here's my patent right here. All right, there you guys. Here's my patents on Google Patents. And you can take a look. You can download the PDF. It's free. Free to take a look. All right. Let's see. I knew it. SS138 protocol logic. Yep. SS. I knew it. Oh, gloomy traffic. Do you have experience with XGBoost? I have not used XGBoost before. I would like to try it out. XGBoost someday. Patents are impressive. Thank you. Gloomy traffic. Appreciate it. XGBoost someday. Sounds exciting. All right. So yeah, got patents here, you guys. That's all we need. C and Rust, there you go. Is all awful. Oh, C++, yeah. Yeah, you only need C and Rust. You don't need the C++ part. So thank you so much for telling us about that. GCA, absolutely. Yeah, absolutely. It's been a lot of fun. I did this all in Silicon Valley, you guys. This is where, tech capital, very prominent. And now we're teaching you guys how to do machine learning on YouTube. Yeah, crazy how things work. Using XGBoost for a financial prediction model. Hey, there we go. See? We're doing the same things right now. That's crazy. You're doing something probably a little bit more like real world. We're just building toys over here. We're just building toys. Stephen, Pubnum is useful for swarm robotics. Yes. There have been many instances, unexpectedly, where swarm robots, yes, because our technology is very, very fast and efficient. Very, very fast and efficient. It's able to do what you call lockstep broadcasting. So if you want to command and control a swarm, you can use our communication bus to do that because of how fast we're able to replicate packets that go to each of the devices directly. That's what we do. Yep. All right. Let's see if we can figure out how to do this AI stuff here. I know we're going to do it. I know we are. We're going to figure it out. X. So we got our inputs and we got our weights and bias. This one's actually really easy. So we got our inputs. We're going to matmult self.weights, self.wei weights, plus our bias. This right here is the most influential and popular feed forward you've ever seen yourself in. Creepy but awesome. Yeah, a little bit. Yeah, I think so too. C++ is on the bare metal, nothing else faster. C++ is pretty solid. Low-level logic rules. Yeah, it does. It's so good. I really like it. I like it too. We'll do more of that too. So we've got a lot of time on our hands, you guys. We're going to be able to go through Haskell. We'll go through C. We'll do some more assembly. We can do some C++. We'll do everything. We'll make it all good. Nice wonder Pubnum have any ROS2 SDKs. What is a ROS2? I'm not familiar with Google ROS2. What is that? Oh, robotic operating system. Oh, I should know. I feel like I should have known what that is. An open source modular middleware framework for building robotic application. It manages complex robotic behaviors, hardware drivers, and algorithms by dividing code into active agents called nodes. Unlike its predecessor, ROS2 supports real-time systems. Oh, it's an RTOS, multi-robot teams, and production-level environments, you guys. Wow, that's crazy. Okay, ROS2. I didn't know about this. There's too many things to know, you guys. There's way too many things to know. Welcome back, Quick Fix. All right, how fast are your packets, Steven? Very fast. They're so fast. They're in the microseconds. We have exceeded the millisecond. We are in the microseconds now. In the microseconds, Squirrel Sniper. Steven, so actual main product position is the low latency communication bus. Yes. Yes, indeed, it sure is. And we guarantee reliability because we do replication across all of our regions. So that way your message is there. You send one message into our network, we copy that message 30 times. We have your message. We could lose data centers and your message is still available. Yeah, it's really cool. It's great tech. That's in my patent as well. My patent, you guys, right here. You can call me ZS. Oh, ZS. Okay, if that's easier. Excellent. Just wanted to say, you're the kind creator people should learn from. Let's go. Hey, ZS. All right. That's so nice for you to say. Thank you. Thank you very much. Appreciate you. Swarm communication, do you calibrate with military or should we? Oh, we can't talk about that gloomy traffic. Shh. Funny. You didn't hear anything here. We don't. Yeah, secrets. You don't talk about the secrets, you guys. Don't talk about the secrets. Okay, so let's get into this. So this function right here is going to be the main function. This is the main function right here. This one is the simplest function. Exactly. Shh. We didn't see it. Nothing to see. Or no, we didn't. You didn't say anything. Nothing happened, you guys. How much statistics important for machine learning? It's a little bit important. It's a bit important. It's mostly calculus is what we're doing, really. Hey, Porter Jaguar, welcome on in. Good to see you. Happy Saturday. Good to have you here. All right. So this is going to be the most neat foundation part of our model right here. It gets more complex. We're going to go into it. You look like oh, well, thank you. Hey, welcome on in. K5B, good to see ya. Good to have you here. You have made a malware in command. Ooh, although very basic, you can do it. It's possible. I've done it myself. A few times. Okay. Not important to learn code anymore. Just use AI. That's all that's doing the work, right? I know. You don't have to tell me. The AI is taking all our job. No, it's actually just a really powerful tool that's used to print code out. It prints code really well. And I use that a lot. However, I think it's really valuable to also understand the code. And that's what we're currently doing today, you guys. So let's go into the next function. We're going to create a loss function. What we do is we create our predictions and then we have our targets. So this is the forward model. This is like the predict. The AI model is going to predict the answer, right? We're going to get the answer predicted, right? And what we need to do, what we need to understand is what our target is going to be if we get it wrong. If we get the answer wrong, we need to calculate how wrong the answer is. And we do that with a loss function. So we're going to type loss here. And we're going to say what our targets are. Let's see, predicted and true. All right, so here is our prediction and our targets, right? What the actual answer. So the answers and the guesses, right? This is the guesses. From the prediction, we need the prediction right here. So this is the output from this function right here needs to be the value that we pass in here, right? So that's the value that we pass in there. That's what that looks like right there. Deltas, regular file assertion regs, 2 messages you've been, wait. And you've been trolled? It spams with spawning back 5 more times. Porta Jaguar and copies it to startup. I don't follow you. What? What do you say? All right, let's keep going, you guys. So we got our loss function here, and we're going to do mean squared error, which is just the average over the square, I believe. I think it's pretty simple like that, right? It's really simple. So we take the average and we subtract. So we go prediction minus our targets, which gets us the actual loss, like the actual error, right? So targets. So this is the actual loss. We can scale it though. we can scale it. So np.mean, and then we're going to scale this by 2x, which is squared, the squared part. So this is where the mean squared part is. So the actual, here, let's do this. So the actual loss is going to be this part right here. So let's calculate the loss. So this is the loss. And the mean squared error is this part right here. Loss squared. Write that. Return. We're going to return this. Return. There we go. Return. All right, perfect. There we go. Let's see here. Bad naming convention. Oh, wait. We could go further. Always is dims. Dims, right? Dimensions. Is that okay? Did we do it right? VBS for messages and CMD for str up and spawns itself and more. Portage. I might not be following exactly. What are you saying over there? I think you're talking to Squirrel Sniper. Okay. So now we've got our prediction. How do we predict data, right? And then we've got a loss. To calculate the error, we need to calculate the error so we can use this to train and correct the model, right? These things right here. Cap locks is a bit finicky. Is it? Yeah, so what I do with my keyboard is my caps lock key, I actually convert that to a control key. So it's not a caps lock key on my keyboard. All right. Okay, here we go. So let's see what this looks like now. Let's make sure that this can, we don't want to have that anymore. Let's go back over here, you guys. Let's get back into the Python. There we go. Okay, so we're still good here. So we've got our model, we got our inputs. So let me go to the next phase now. Let's see what else we want to do now. So we've got our weights and biases, we've got our loss function, and we've got our prediction function. This is the easier parts. Of all the parts, this is the easier part. Now we have to get into the fitting the model, and we need to get some test training data. So we can do, let's get our test training data. So let's do that part next. We're going to generate data here. So let's do def generate data. Okay. And we need to return an X and a Y, right? So typically when we say Y, this is going to be the targets, which is the actual answer. And X is going to be the inputs, which is the features, the things that we're going to show the model. Like, oh, it's the color red, or it's, in this cursor position X, it's this segment on the screen, or it's these numbers, right? Or it's these letters. This is what X is. It's the input. That's the input part. So X is the input. X equals model inputs. Inputs. There you go. Like that. And then Y is going to be the targets. So we can generate some test data here. Let's see. Let's do some make data. Make some data here. Wasn't that hard? Wasn't that hard? No, so far so good. What theme do you use on your terminal? This is called Groovebox. Groovebox. Oh, wait, I typed that wrong, sorry. G-R-U-V box. Like that. Spelled interestingly. So watch this. vimrc, Groovebox right here. Oh, right there. Apsani. Hey, Apsani. Yeah, exactly. I'm not exactly sure. Steven, like a Richard Silicon Valley, but has a very successful company. Yeah, I do. It's called PubNub. Thank you. Thank you for bringing it up. We're a secure global infrastructure for real-time applications. We do APIs for communication, for sending and receiving messages between devices. We've got over 1 billion devices on my network. Today, we sure do. And I've got my patents here. And you can see them. Yeah, good to have you guys here. Welcome on in. Okay. Yeah, Groovebox. That's my favorite right there. I like Groovebox. Okay. Let's close this out. So we need to generate our data. Let's see. How many datas do we want? Let me take a look here. So, we can create a uniform How do we want to do this? Okay, yes. So let's do a uniform. So we'll do x equals np.random.uniform, and then we're going to pass it input, start, end, and size. We're going to say size is going to equal, let's see, how do we want to do this? I think we want it to be, let's see, and our target output is going to be, so we need features. So we got our input features, and our target output is a binary classification. So this is going to be binary classification, right? All right. So that will be how many features we want. I guess we say dims, maybe dims. But we already know what the dims are. So let's see. So self, we know what the shape of this is, right? So we can use shape. So let's indent this. Let's bring this into a self. So that way we can grab, we don't need the dimensions anymore. We already know what they're gonna be, right? We already know what they're gonna be. Let me take a look more of my notes over here real quick. Here we go. Okay, seems good to me. All right, fine. Okay, so let's keep going. I want to do, how many, see, dims equals self.weights shape, and I think that is shape 0 right there. Hey, boss gangs, thank you for following. Good to have you here. You joined the right channel for software engineering. We're currently doing an introduction to machine learning today, and this is going to be linear regression. And we're going to do the best we can to build something for you that shows you an actual working model. That's my objective today. I think we can do it. I think we can. Yo, Retro, good to see ya. Welcome on in. Happy Saturday. Good to have you here. Welcome on in. Sup? Okay. All right. And we will make a few mistakes. Don't worry. Along the way, we're going to learn. We're going to learn, you guys. Lock in, bro. I know, right? Lock in. So dimensions and 1, because this is binary classification. So that'll give us our X data. And we're going to return X and Y. And then Y is going to be equal to X, and we'll just like modify Y slightly, right? Modify X slightly so that way the model can learn, because it's a linear model. So we can't do anything too crazy with this, right? So we can say like plus times 2 plus 1, something like that, right? Can we go any further? I think that's fine. I don't think we have to go any further than that. So then we've got our X and Y. There we go. Return X and Y in dimensions. I think that'll work. Maybe. I need to see. Print. Let's print this out. Double check here. Let's print that. We don't want to forget. We don't want to forget it. So today I didn't sleep a whole night. Oh, Retro, no. Any other day? However, this time I made your own ChatGPT basically. All right, using Ollama with Mistral, locally running with a GUI chatbot. Looks exactly like chat. Nice, Retro. Good to hear it. You're doing some good work over there. Excellent. Okay, so we're going to generate our data. This is going to be the input data. These are the features. What are the colors? What are the numbers? Wait, maybe your numbers are stock quotes, right? Maybe you're doing stock quotes, or maybe your features are like housing data. You want to say whether I want to give someone a loan or not. So I can get the housing data. I can get the input data, like how expensive the house is, how old the house is, what neighborhood the house is in. Those are features, right? And then I can say the output will be some extra numbers, maybe something like that. I don't know. This is not quite binary. This is linear. This is not binary classification. You could make it binary classification. This is going to give us, it's basically going to fit. It's going to fit the value. It's going to create an equation that allows us to create a prediction of the future. So this is more prediction value generator, right? And we can train it. We basically fit the model. So let's see if let me see if I can show you like a graph here. Linear regression graph example. Yeah, there you go. Yeah, so we're going to have all these data points here, and that line is the fit. So we're trying to generate a line that fits onto that graph. So that way you can see as the values change, you can see what direction they're headed. So we can predict the future with this approach. What do you, wait, do you actually do that, Stephen? Oh, I do this a lot in finance. Yeah, I sure do. Well, is that what you're talking about though? Is that what you're referring to? I'm not sure though. I'm not sure. You slept today? Me too. I slept today. I slept pretty well. I slept very well. All right. Thank you for the hearts, you guys. All right. So now we've got some data. We've got our loss function. We've got our prediction function. And then we've got our actual parameters of our model. It should know C more than Python, honestly. The AIs. It should, because C's been around for a lot longer. You're talking about determining loan opportunities or whatever. Yeah, I do, yes. We do in finance. So there's a lot of linear regression that needs to happen. So it happens, here's how you do it. So this is how you can use it in business. This is a real world business use case for this math right now. All right, that I've used it for. Predicting revenue by cohort and industry, right? That's a real thing right there. Yo, let's go. Linear regression rocks. Good to see you. Good to have you here. And Ale, hey, how's it going? Ale, good to see you. Welcome on in. Thank you for saying hi. Question mark. No, what the Discord link is? Oh, we can get that for you. Retro. Let me give that for you real quick. Here we go. General chat, copy link. Okay. At retro. There you go. Discord link. That's awesome. Yeah, it is. It's pretty cool. And I've done it for other things like likelihood of deal closing, right? So we've got a lot of deals in the pipeline and we got a lot of data about those deals. So we collect all those data points and I convert them into, it's called what do you call it? It's not vectorization. It's you take the features and you enumerate them and then you collect the classes that each of the features of the inputs from all of the prospects have. Like I know what their domain name is. I can do a reverse lookup of their domain name, see what ISP they're using. I can see where their company is located. How many employees do they have? What's their current revenue? What's their tech stack? You can take all that data as features and input in your linear regression model and then do a prediction on close or not close. What data sets are we using? Must be something interesting. Well, I gotta tell you, it's a bunch of random numbers. Hey, we're out there. Do you see that? Bunch of random numbers. Hey, how's it going there? Vipinov, you know what? Java? Nope, no Java here. I see what you did there. You're trying to bait me. You're trying to bait me. Bait me with Java. I know. So technically you could take down Twitter. Gloomy traffic? Well, yeah, there is a way to do it. There is. They do protect themselves though with a CDN. So content delivery network. Logistics regression. Hey, yeah, there you go, you guys. There you go. Feature engineering is tough for finance. It is, right, Rox? So you have to find all the features that you've been put into your model. Yeah, so we're using toy data right now. So we're going to show you how to do this with toy data. Welcome to the Discord, Retro. All right, how long will it take as a beginner to learn Python? Pretty quick. It's pretty quick, right? So go to your computer, in a terminal window, type Python. You can say 1 + 1, a equals 1, a plus 2 is going to be 3, right? And you can say b equals 5. You can say a plus b is going to equal 6, right? There we go. We got ourselves some numbers. Then you can also say a is a bunch of numbers, right? 1, 2, 3, right? Now a is a vector. A is an array. It's got a set of numbers, right? You can do all sorts of fun things. And then if you want to access an element inside the first element, there you go. The first element of A. First import this. Oh, import this. Hey, there you go. Take a look at that. The Zen of Python by Tim Peters. Food, yep, there's an Easter egg right there. Bet you guys didn't know about this Easter egg. Import this. right there. A little bit of Easter egg, you guys. All right. Yeah. Oh, I did it in 1 year, but like advanced Python. Yeah, you can learn all of Python in a year easy. You'll test a C example and code for your own. Oh, hey, nice. For Jarvis chat. Retro, very nice. So what do you need for study? For a job? What do you need to study for a job? I recommend full stack. All right, let's say what to study. Things to study for. All right. So if you want tech job, I would say a full stack, which is things like server, backend, Node, Node.js probably. I mean, that's like the standard right there. A little bit of Node.js, and then you'll do some front end. So you do React / I don't know, maybe Angular / what do you call it? Svelte / Vue, right? Got some front end stuff there. You also want to do some CSS, HTML, right? You want to do some databases like PostgreSQL, MySQL, or SQLite, right? You can do those things. Lots of things, you guys. Hey, Domalier, good to see you. Welcome on in. Good to have you here. Happy Saturday. Do you ever start your own anime? Oh wait, if you ever start on your anime John Hilbert villain, you need to buy a cat and stroke it during your lives. That would be the true sign of a villain. Front end, yes. Front end, yeah. We should add lower fine tuning to this, the future stream plans. All right, let's do it. The good news is we've done it before. We did it live. All right, so let's go here. We'll open up our README. Let me see here, README. We say low raw, which is low rank adaptation, fine tuning. Right there. Tuning. Fine tuning, you guys. Low rank fine tuning. Yeah. Do you have to be SOC 2 compliant to have no clue and keep? Yes. You need SOC 2 if you're going to be dealing with other customers' data, for the most part. I would say, yeah. You can finally watch using 1080p. Oh, nice. Fantastic. 1080p is the limit of all the limits. It's full. It's HD. It's HD, you guys. Domestic cats are the only ones with those reptile eyes, which always throws you off. Steven, you read your patents? Oh, nice. You've read? No way. That's like a feat. That is so cool. Yeah. All right. How much did you cost to copy the images to all the servers? Do you remember? Wait, how much did it cost to copy the messages to all the servers? Do you remember? Yeah, I know very well. Because I'm running it right now. I've got the data. I've got it. I've got the live data right now, you guys. It's not cheap. It's not cheap. It's in the millions of dollars. It is. Don't look at me. I didn't say. Let's see. I don't like to talk about that stuff. I like to just talk about the software side of it. I just like to talk about the software side of it. Steven, I've read your. Let's see. Yes. So can I freelance with Python oriented object? Yes, I think so. Yeah, absolutely. There you go. You guys asked. I'll let you know. All right. So yeah, we can do some low rank adaptation in the future, which the good news is I have done it. We've done it live on stream, so we know how to do it now. You would dream of that money? Don't worry. We're all in the same spot pretty much. Because, hey, do you watch anime? Do you play video games? Do you go outside and walk around? Do you use your computer? Do you use a phone? That's all I do. That's what we do all day. It doesn't mean any different. Hello, like done. All right, Arsalan, yo, bro. Good to see you. Welcome on in. Happy Saturday. Are you guys watching GDQ? Summer games done quick. SGDQ. Like some SGDQ there. Today's the last day. How's SAQ similar? ID SQL similar to Python? Well, they're different things, right? They're very different things. So SQL is a domain-specific language that's used to query with aggregations, filtering. What are we learning today? We're doing introduction to machine learning. We're going to be doing linear regression, where we're going to predict values. We're going to predict the values. We're going to say so like, for example, what we could do is we could say house prices over a year, right? We can see how the house price changes. We've got all the past data. And then what we can do is we can use linear regression to predict the future value in 10 years from now, right? That's what linear regression does. Do you think AI should be controlled or limited in the future? I think that we should make it available to everyone. I feel like just open it up. Let's open it up to the world, you guys. Oh, well, oh wait. Rutura, the classic California house price prediction. Yes, exactly. Exactly, that's what we're doing. You got it. You know it. Precisely. Is SAP good? As a platform, do I use it? No, I don't think I don't know. I don't have an opinion because I've not done it before. I've not done that before. Hey, Don Malier. All right, so money doesn't do anything. Rich people complain about it all the time. End up gambling or doing all legal stuff. I mean, you probably could. SAP is good. Food. Okay, so we got an answer, you guys. SAP equals amazing. All right. We've got proof. We've got proof, you guys. SAP. Oh, wait. It's the opposite of that. Oh, I got that wrong. Whoops. Sorry. No. Take that back. I take it back. Wait, let me redact that. Let me redact that. How do we do that? Let me see. Can I delete that? Okay, run away. Avoid it. SAP equals avoid. Sorry. I misread you. That could have been, so I thought there was a the in front of your word. Like, SAP is the. I misread it. I thought I saw the word the in front. I'm Rox, less with traffic here. Oh, okay, Rox. Good to have you there. Thank you for joining. Hey, you've got the full screen now. You've got the full screen. It's 11 p.m. here. It is 10 a.m. over here. Got 10 a.m. So here's a good general start for your tech stack. Right there. Good general start. Good general start, you guys. Let's see. Okay. If I missed your chat message, just let me know, you guys. A lot of chats here. End up on Epstein. Oh, because they chase exclusivity. Yes, exclusivity. Uh-huh. You're living in Asia, so there is a massive time difference. There is. Yeah, it's like early morning for me. It is. Actually, I wake up at around 4 a.m. and I go to sleep at 7 p.m. my time. So I'm on a different time zone over here than everyone else in my area. Okay, so let's bring this back, you guys. Let's bring this back. Let's go back to our machine learning. Let's keep going here. All right, so where did we leave off? We've got our inputs, which are going to define the parameters of our model, which are going to be weights and biases. You can see them here. Basically, it's a bunch of numbers. Basically, it's like 11 numbers. That's what we're doing. Can we do it on Titanic dataset from Kaggle? Maybe we could. Let me see. Let's find out. Let me find out. Because this is just linear regression. So it needs to be a simple number on the output. It's also beginner friendly. Google Kaggle Titanic data set. All right, let's pull this up here. Titanic machine learning data is disaster. Here we go. Let's look at the data. Let's take a look, you guys. Training, test. All right, let's download. Where's our download at? Where's our download link? Would be nice if I could preview this, yeah? All right, survival. Ticket. Oh, all right, so this does count. Yeah, this looks about right. I think so. Have you ever watched Professor Jang? His channel called Predictive History, where he applies game theory to history and psychology. It's a pretty unique idea. I've never seen this before. I've never seen that, Kyle. I'll have to go check it out. All right, you guys. So yeah, look at this. All right, so this would require us to vectorize our data, or encode the data. Basically, it's called encoding. So yeah, let's download this. Download all. I want to download via. Oh, look at that. Oh, there's a nice little layer. Look at that. Okay. Path to file. That's not that nice. Wait, can we do? I just want the data. Let's see. And then we need a CSV importer, and then we need to convert the data. Okay. So let's do this. Let's put this on the to-do list. So let's keep going on our linear regression, and then we will do lesson 07 with Titanic data. Here we go. Let's paste that in here. The Titanic data set. Okay. Thank you, Rocks. Appreciate it. Rabbit hole, but there are some incredible insights. Nice. Hey, Yuval. Thank you for saying hi. Good to have you here. Happy Saturday. Welcome on in. All right. So this will be our lesson 7, where we'll actually use real data. We'll use some real data there. Okay. Let's bring this back over here. Okay. So now we've got our loss and our prediction. What would be neat is if we used our test data, which we've got around here somewhere. We got our test data. And then we need to figure out how I want to do this. So let's do that. All right, so let's do data equals model.generate data. Let's see here, and we'll print our data. See what that looks like, yeah. Professor Jang is famous in geopolitics and secret societies. Oh, I had no idea. All right, what kind of machine learning? The kind that we're doing today is called linear regression. This is where we're going to be able to predict a future value. We take a look at the screen. Basically, you fit a line to a bunch of data points, which is going to give us basically a slope. We're going to get a slope in here. And this is just a single line. So this is linear regression. And it's going to allow us to either classify if something is or isn't something, or it can give us a future predicted value. So if we keep going on the x-axis further out into the future, right? We're going further out into the future on the x-axis, like beyond where we see here, we can predict the future of whatever the y-axis is. Rich people problems, specifically addressing society's power structures. Ooh, there are things, I know people, they are interested. They're interested in doing this. They are, because they have nothing else to do now. They already won the money side of things. So yeah, so we're going to be building this. And then when we calculate the error, this is pretty neat. So we take all of our input data points, we find the error, and we're trying to minimize the error, which changes the slope, right? So we change the slope. And that's the calculation that we're going to do right here. Just stopping in real quick to say hello. All right, Slick. Good to have you here. Have a good day. From San Francisco. All right, you're over there in Silicon Valley. Mean squared error, MSE. You got it. You got it. NumPy operates entirely in memory using synchronous blocking operations and centralized CPU. It does. Actually, Squirrel Sniper, yes, you're right. For an industrial real-time telemetry and event-driven stream processing framework, this creates a data bottleneck during execution unless you parallelize it. You could. You can throw it across multiple CPUs. Read your message. What'd you say? Quick fix. What kind of machine learning? This is predictive linear regression is what we're doing. So this, the kind. So there's variety of kinds, right? You've got reinforcement learning. You've got supervised learning. You've got clustering. The kind that we're doing is supervised learning. I think that might be the answer you're looking for because we already have the data. Supervised learning is when you already have the data. And then unsupervised learning is when you have just a series of data and can predict the next value. So something like ChatGPT, that is predicting the next token, just reads a whole bunch of data and it predicts the next word. That is unsupervised. It is essentially, you don't know what exactly it's going to, it kind of is supervised learning. It's just not necessarily going to give you the exact target answer. You're not regressing over anything, I don't think. I could be a little bit wrong about that. All right, so let's keep going, you guys. So I'd like to see what the output looks like on this. Let's see what this looks like here. All right, take a look here. Okay, here we go. So we've got a bunch of input features of dimension 1, right? And it looks like we have 2. So we've got our inputs and outputs. So our target output for each of the inputs. Now, is that the way I want it to be? Let me think about that for a second. Does that look correct? Let's see here. Size 100. I need to think about this for a little bit. Because when we're passing in our X into our forward, does that look correct? You shared a screenshot of your Java chat? Oh, in Discord. We'll have to check it out. Have you heard of a Prof. Van Betts from University of Toronto. I'm hoping to talk. I've not. Oh, hey, I was going there. Mad have. It's late. All right. Starting to learn Python. All right. Sounds good. Sounds good. Appreciate it. Appreciate it. All right. Let's keep going. Let's see here. General chat. Where'd you put this? Hey, how's it going there, Krish? Good to see you. Welcome on in. Happy Saturday. Good to have you here. Yes, you can talk into it. Let's see here. Where'd you put? Oh, here. Look at you. This is what you built. Hey, take a look at that. Very nice. You've got your own Jarvis. You built your own Jarvis right there. Nice. Good job. And it even prints out code. Ooh, fancy. Fancy. Looking good. Very nice. All right, so I'm not sure if I'm satisfied with this data that I generated. I do not know if it's going to do what I want it to do. Let's try a forward pass. Predictions equals our model, and we'll say dot predict, and we'll say data, and we'll print our predictions. Print those predictions there, you guys. Let's see what that looks like. Yeah, see, this is what I thought. This is where I thought it was going to not work because I need it to be in the right shape. It's got to be the right shape, you guys. It certainly does. So how do we do this? Our input features. Do I need to do any transposition? I might. Oh, wait. Data, comma, lab targets. Let's try that. Thank you for the reactions, you guys. Thank you for the hundreds. Appreciate you. Here we go. All right, self.weights. Linear regression object has no weight. Oh, I typed it wrong. Let's see here. Weight. W-E-I-G-H-T-S. Let's make sure we spell things correctly. Okay. All right, there we go. Now we're on the right. Size 10 is different from 1. So we need to do this differently. How do we want to do this, you guys? Let's do dims. I know we could do dims, but it's not going to be exactly what we want. Okay. So let me see here real quick. Okay. So, whoops. Not there. Here. Where's our uniform at? Here we go. Let's try that. Okay. There we go. That works, but it's weird. And I don't know if that's what I really want. It's because it's always going to be 0 because we've initialized our weight to 0. So it's always going to be, the output's always going to be 0. So we're going to have our features here, right? Our features. And then we're going to have how many of those we want. So let's say we're going to have like, I don't know, let's do 1 for now. We'll do 1. All right, perfect. Okay. Here we go. So we've got 1 sample, and then we've got our sample output, and then our values. All right, so let's say here, print data. There we go. We're going to say print model, so we know what we're looking at. And then we'll print our predictions, so we can see what that looks like on screen. And then we'll add a new line character so we can see it a little bit better. Print at the end there. Save, reload. Okay. Our predictions. There we go. Is that right? Is that what we wanted to see? That seems like I'm not sure about that. I don't think that's exactly what I want. Let me think about that. Okay. Let me think. All right. Our X is going to be a uniform within examples with 1 feature. Let me see here. How many features are we going to have here? 1 second. I'm looking over my notes, you guys. I want to see where we can find this at. I want to make sure to do this the right way. Hey, how's it going over there? Python. Yep, we're doing some Python. You know it. Got some Python going, you guys. Okay, so I want to... Now what we're doing is we're throwing data through the model. We're going to see what the outputs are. And this is a debugging process where I make sure that all of our parameters are in the right shape. All of our parameters are in the right shape, right? So we've got our inputs, the input dimensions, and the outputs. Oh, that's the inputs and outputs. So we can see how many classes we want. Classes, right? We do that. Classes like that. Is that what we can do? So if we update this linear regression model to say 10, 2, we get our outputs. Our prediction should have 2 values. Hey, look at that. 2 values right there. All right. Looking good. 3 sheep. Hey, how's it going? Welcome on in. Happy Saturday. Good to have you here. Akash, welcome on in as well. Thank you for joining. We're doing our linear regression today with our introduction to machine learning. We need distributed systems live with C or Rust. Oh, you want to build that? I can show you some really good distributed systems, right? Really good distributed systems. We're making our way, you guys. We're making our way. Okay. So now we've got our predictions and we're going to output 1 class. I only want 1 class on the output. 1 class on the output. Let me print my targets. I want to see what my targets look like, yeah? Let's do the targets as well. I want to see that. I want to see, wait, this is not correct here. Hold on. Predict only returns 1 thing, and I need to capture my targets here. So these are features. There we go, features. Updates to features. All right. We get our model, we get our features, we get our targets. Let's see. I want to also print this out, right? Targets. There we go. All right, looking good. And then we'll get our predictions. And so the targets need to match the predictions. That's basically what we want to do. We're going to get very low. Hey, Bug Boy, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. Good to have you here. You know, I was doom scrolling and found Peak. Hey, that's great to hear. Well, thank you very much. Good to have you here. Do you know any good free AI agent for coding for Android? I need it for a plane tracker or edit something. My favorite is Gemma 4 and is decent. Make sure to get the IT version, the instructed version, right? So you can do chat with it. So it'll actually print code for you. Get the IT version. Gemma 4 IT version. That's the one you want. Right there, you guys. See, do you get these text to speech thing? Yeah, the text to speech. This right here. You mean speech to text? This is like voice into text, right? So it's like right there. Looking good. This is software I wrote many years ago. If you want, it's open source and free and available for you. It is on our Discord server. So if you want, you can just grab that link from our Discord server. Is it 100% free? I don't want to spend money. Yes, free. You just need to have good enough hardware for it. There's also a online version that's free, right? The thing is search for the whole day. Yeah. So I think what it's called, AGY command on your terminal. You can maybe even Termux supports it, right? Maybe Termux. That might be good. Thanks. We'll check it out. Yeah. It's called Gemma 4 IT instruction. That will let you run the model locally. You can also do, I believe Google gives you a free coding version. So you should do the free coding version. That'll do the trick. All right. So let's keep going, you guys. Let's see here. All right. So targets. I'm going to see what the output looks like on this real quick. All right. So we got our features. Have you heard of RULAD, or the theory of universe? At its core is a computation, not like software, but there are rules. What do you think? Can we use computation to understand nature? And finally, the universe. We'll need to use the universe. We need to use nature directly by calculating at the universe scale, which is going to be the quantum. We need quantum computers to do that. That is going to allow us to calculate the universe itself, because we have to use nature because of the scale that universe is at. It's so big, it's so massive, and there's so many particles everywhere right now. They're all around us. Be careful. So we need quantum computers to do that. Absolutely. All right, so we got our features and targets. Does that look correct? No, our targets need to be different because our output, our classes are going to be different. So we need to change this here. We need to change this data. Like reverse engineering nature. Yeah, rocks, exactly. We're going to reverse engineer that nature. We need to use nature to calculate nature. That's what we got to do. Automating the frequently asked questions for live streamers could be interesting as a live feature, but that would be wild. Yeah, that would actually be a pretty good idea because there's a lot of common questions, like a bot. Yeah, for example, a bit of answers their questions. Yeah, a bot that answers their questions. That's a pretty good bot. There's a lot of common questions. You know it. Absolutely. A lot of common questions, you guys. Okay, let's keep going. What are the Gemma link I don't found on Discord? Oh, there's a Gemma link. Yeah, okay, so let me see if I throw the Gemma link here. Gemma for IT. Hugging face. Here we go. Here, this is a good one. This is a pretty good one right here. I will send you the link here on link share. There you go. On link share right there. There you go. And that talks like Steven. Oh, yeah. Hey, like that video that you shared the other day. That would be fun. I want to build that. I want to do that. I want to copy that video. That video was great. That was a good video. XD retro. I remember XD. I like XD. Let's see. All right. The amount of cumulative time you've spent explaining this stuff adds up. It sure does. It absolutely does. Okay. Yes, vibe code it. Always vibe code it. Yeah. That would be a lot of fun. I would like to do that. Quick fix. I think that would be great. That would lessen the joy of interacting in the stream. Hey, yep, rocks. Yeah, don't worry. We won't stop on the stream interactivity. Don't worry. We'll definitely keep going there. I promise. I promise we will. We will. Don't you worry. Don't you worry. So our targets need to be different here. We need to change our targets. Our targets should be related to our X, but in a different way. Right? How do we do that? Let me see here real quick. Because I need our targets to match our target classification outputs, so that way we can calculate our loss function correctly based on our predictions, because our prediction outputs are right here. Whoops. Ooh, I don't mean to do that. There we go. Yeah, here's our prediction outputs. So we need to fix this. We need to fix this part of it right here. Let me go through. Let me look at all of my things. Let me see here. 1 second. I'm looking at my notes here real quick. Let's see over here. I want my data generator. Here we go. All right. We got the right examples in one. Oh, okay. I see. Yep. So that's input and no. So that's batch and examples. Interesting. Okay. So I don't know if okay. So I need to think this through. I need to think this through in order to make this work, you guys. This is the more challenging part here. So let's see here. Number of so this is more like the features, the inputs. So this is where I messed up. The number of features here. One feature number in the number of examples. So this is examples, right? Number of data samples. So data samples, number of features. Samples. There we go. Oh wait. No. I always mess that up. Hold on. That was our init. We don't want to deal with that. That's fine. That's fine. We don't want to touch that. The generate data is where I need to change that data. Here we go. Okay. There we go. All right. So let's see here. All right. So we've got our output them. All right. So this is features, and this is going to be number of examples, right? Features and examples. There we go. Features, examples. And then we can throw those over the parameters. All right, so let's see here. Samples, data samples. Data samples. It's going to be here. Samples is going to give us the batches, basically. The number of total samples that we're going to generate, basically, for the most part. The only thing now is my Y looks weird. Right? My Y looks weird. So we need to figure out how to fix that. Let's see here. Number of classes. Okay. Let's bring this back down to 1. A little bit of a decrement there. Okay. Back to 1. Looking good there. Okay. Now we need to linear regression, classes, dimensions. Okay. That looks good. HS, good to see you. Welcome on in. Thank you for saying hi. Good to have you here. Happy Saturday. Welcome on in. All right, so we're doing some introduction to machine learning. We're doing linear regression, which is kind of like a little bit more hard mode, and I need to make this work. I know what it's supposed to look like, and we're very close. We're not far off. Do you ever use sliding windows? Yes, I do. I do. Slide those windows. So you've got your data set, your entire data set, right? And you want to take snapshots or little slices of your data, and you can slide over your data, right, to get a slice of your samples. And when you do that, you can repeat those slices. So this gives you your model the idea of what things look like in a sequential model. Usually it's a sequential model, right? So you can slice over your windows. I like that. Vibe coding isn't bad. Yeah, it's the holy grail of AI development the whole time, but now the real developers are the ones who turn it down and people take, oh, right, retro, well, you know what? I think the best engineer would probably be the one that uses both. Maybe uses both. So thank you for the hundreds, you guys. They use coding when they know they need coding just for like quick small things, and then they can sort of guide an AI to write larger chunks of code. And they know what the code should be, and they know what that conversation would look like to drive the AI the best. Dynamic sliding window is scary. Ooh, dynamic sliding windows. Oh yeah, you gotta be careful, especially if you're gonna throw that into a GPU, because each of those sliding windows requires a different shape, and that requires additional kernel compilation. So for every shape change, you need a dedicated kernel. It's required, right? And so if you have a dynamic sliding window rocks, you have to use a lot of memory just for those sliding, for the dynamic part of it. It's better to put in what they call padding, like zeros. Just put in zeros and ignore the zeros. That's better. That's a slightly better approach. Write notes, to-dos like Steve is doing here. Step by step, progressing. That's great. Yeah. Smart fella. Thank you. Appreciate it. After clicking the link, where do I go? Sorry for bothering you. Oh, so 3 sheep. Are you... It depends on how you're trying to run it. Because you might want to run it on Ollama. Or, right? You can run it on Ollama. Or do you want to run it with Python? So, here. Watch this. Click on the link. It says use this model, and then you can use it right here in code. So you can use the model right there in code. Really straightforward, right? Maybe not that straightforward. If you want to use it more easily, I recommend Ollama Gemma 4. Ollama Gemma 4. This is a little bit easier. When I say a little bit, I mean a lot of bit easier. So I'll also paste this link in here. So if you want the easier option, that's the easier option. No dynamic sliding. Information retained. You gotta be careful there. Skip the unnecessary headaches, yeah. Codex does so many unnecessary changes. You found Codex does more changes? Yeah, you gotta like let it know what you want it to do. All right. Yeah, so you got a couple options here. You can use Ollama, which is easier. And then you can use the model directly if you want to use it in code, which I thought is what you wanted to do, but I wasn't sure. Okay. So we need to fix this right here. Our targets look incorrect. You guys. So how do we want to do this? So I want to calculate some input features. We could do a bunch of input features, and then we need to calculate what the target output is going to be, right? And we need to converge on this. So this needs to change here. Here we go. All right, generate data is missing an argument. Generate data, we'll say like 1 sample. Try that. Okay. Does that look correct? Features. See, here's where the problem is. My target needs to be a single value. and it's 10 values. So this is where we need to make change. Also, it's identical. Oh, because did I type it right? Oh, I didn't even type it right. Here. There we go. All right. So that looks better now. Finally, an engineer, intelligent streamer. Oh, hey, Casablanca. All right. Good to have you back. Welcome on in. You're doing a world favor. Cheers, bro. Thank you. Thank you very much. Glad to have you here. All right. Let's see here. Close that out. Ooh, okay, here we go. Copy that. Okay. Python lesson 6. Okay. Yeah, we're currently doing introduction to machine learning. Over the past couple of streams, we covered basic array vector manipulation, right? And now we're doing linear regression, which is a step up. Now you're into real machine learning world. That's what we're currently focusing on. We're doing some linear regression right here. The regression line, you guys. Let's see if I bring that back. Can I bring that back? Linear regression right here. Oops. Let's close that out. All right. So all these lines, those are the regression lines. It helps fit to minimize the error across all of your data samples. So that way, as you're projecting forward on your X line, then your Y line can be a lot more easily predicted. Hey, good luck givers takers. Good to see you. Good afternoon. Welcome on in. Good to have you here. Happy Saturday. And I currently have a target dilemma. My target does not match what my desire is. So my target needs to be a different shape, I believe, in order for it to work correctly. So I'm trying to figure out how I want to deal with that. So I've got number of samples and number of features. Let me see here real quick. Let's see here. All right. 1 second. I'm looking through my notes really quick so I can see what that's going to look like. Okay. Predict. We'll get our error. And then we've got our... Oh, interesting. Okay. Mean squared error. Yeah, we're going to do a mean squared error here pretty soon. Okay. Very interesting. Oh, weird. Okay. All right. Weird. Regular shape error. Okay. Then we have to calculate gradients. And then we do a training cycle. And that's it. So right now I'm just trying to make sure that our Y looks correct. Currently the Y, as you can see here on the screen, looks a little weird. So right here, the targets, the Y, it needs to match the same shape as the predictions. Vim or NeoVim? Oh, this is Vim. Just regular Vim. Ordinary Vim, you guys, right there. Are you using theme? Yes, Groovebox. Looks really nice. Thank you. Number 1. Oh, wow, look at that. How did you do that? How did you achieve that objective? Very nice. Yeah, so this is Groovebox. I like this theme. So we go tilde/.vimrc. Where's our vimrc? Here you go. Groovebox right here. Color scheme. Right there, you guys. A little bit of Groovebox with a background dark color. I'll really like it. I also like Molokai, which is a lot brighter. And we might switch over to that here in the future. I like to go back and forth between those two every like 5 years or so. So maybe we'll switch it up here. Okay. Let's leave our vimrc. There we go. All right. So yeah, I need to fix this, I believe. I need to look through my notes to see why I have it a different way. Thanks again, sir. Well, thank you. Absolutely. Good to have you here. Appreciate your time spending with us today. We're just doing a little bit of machine learning here. All right, let me see. So my inputs and my outputs, they are weirdly matched. So let's see. Let me see what I make. Thank you for the hearts. Appreciate it, you guys. Appreciate you being here. Let me update there we go. Perfect. Okay. X and Y. All right, let's see if we can find our Y here. Train. We got our Y on our train. Calculate the gradients. Interesting. All right, receive lower weights. Self-weights as in plus bias in Y. Oh, so you need the line. So the bias helps you fit the line differently. So you see how there's a slope. Let's see if I can find this here. I'll try to zoom in on this. All right, so you see how this line here has a slope? See if I can zoom in a little bit better. Slope here. There we go. So this line here has a slope, right? It can like rotate. It'll be like a line, right? It's a line that does this sort of slopey thing, right? And you find and it fits. However, you need to also move that line up and down. So you see how this line it can move up and down like this, right? So that's what the bias does. The bias moves the line into the right spot. So you've got your slope, which says what direction pretty much the line goes in, and then you've got your bias and tells it how far to move it up and down, right? That's how that works. A little bit like that. Yeah, so this line right here needs to be moved up a little bit or moved down a little bit to fit all these data points. You wanted to try NeoVim lately, but the NeoVim has a tutorial about 1,000 lines. Uh-oh, that seems pretty daunting. Got a best of the XDDD. Yeah, and I had to laugh it off. Yeah, a little bit confused, continuing the read. Nice, all right. Retro, very good. You see your app link to share? Ooh, whenever you get a chance to check out the progress, I'm curious to see how fast you can find an issue. I can time you. Do you need a login? Yes, let's get a login going. Let's get a login going there. Hey, Heritage. Oh, Heritage. Heritage, thank you for subscribing and joining our channel for software engineering. We're currently working on machine learning introduction. We're building a linear regression model, and I'm doing the best we can do. And I do note that I've got a single little challenge here where my y function is doing something weird. I mean, I know y is pretty simple to calculate. I just think we need to go a step further. We need to go a step further because our y needs to match our target outputs, right? We need to match our target outputs. And we could unify them. So that way they are 10-10, right? However, I'm not sure if that's the right choice that we should make. I don't know if that's the right choice. So let me do 1 by 1 to make that a little bit easier to read. So we can do a 1 by 1. However, that means there's only one input feature, which I think is okay. Maybe we'll just keep it simple. Yeah? We'll just keep it simple and we'll do 1 by 1. Does that sound like a good plan? All right. So we can generate like 5 samples. There we go. And we got our targets, our features, and our targets. There we go. And then our prediction, which will be 0. And so we'll be able to calculate the error with this approach. So this works very, 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 it's like X and Y only. So we're basically going to get our X and Y, which is going to be a single point on the chart. So one input feature, one output prediction. That will probably make it a lot easier for us to deal with this today. Okay, just to keep things simple. Kyle, let me know when you're interested in taking a look at that. We can jump in and take a little detour and check out the app. All right, real quick. Okay, so let's see here. Now we go into, we need to, okay, now that we've got our inputs, just let me see where we're at right now. We've got our model weights and parameters, our biases. We've got a generator, which outputs data in the right shape. In our case, we are doing it using this approach, okay? We've got our predictor, which is the forward method. The forward method will do a matrix multiplication on the weights and then add the bias. What problem are we solving today? Oh, hey, how's it going there? Born to do it. Born to do it. Welcome on in. Happy Saturday. Good to have you here. We're doing a little bit of an introduction to machine learning. We're doing predictive linear regression. So that way we can predict the line and see where the next value is potentially going to be. So if we say in the future, like 20 years in the future, where do we think the value of y is going to be? We can predict it. That's what we're showing how to do in code. So we've got our initial weights and parameters of our model. We've got a generate data function, which is going to generate basically random noise. So it's going to generate these data points here. Then we're going to fit the model. We have a prediction function. We have our loss calculation. And now we need to start the training process. Happy Saturday, predictive linear regression, math trends. Yep, you got it. We're going easy. We're going simple, straightforward. Although linear regression is a little bit more. Are you using Z? This is Python. We're doing Python. Z. Wait, Z is, let's see, Google Z. Is it a programming language? Language? I've not used Z before. Is this the term Z language usually refers to the Z data query language? Is that right? What is Z? IDE. Is this an IDE? There's a lot of Zs out there. Let's see if there's a picture of it. Yeah, oh, we're using Vim. Z IDE versus, yeah, there we go. Okay, yes. So this is Vim. Here you go. A little bit of Vim there for you. Regular original Vim from many, many years ago. Many, many years ago, you guys. Not being math guy, what's your data pipeline before I dig into tasks? Oh, wait, what is your data pipeline? My favorite is SQL. I'll go with SQL first. So SQLite, I really like that one because it's so versatile. I can just pipe all my data into a table and then I can do query data analysis over it. It's my favorite. Nice. Yeah, Broco. All right. Brocode. Thank you for asking. Good to have you here, Brocode. Yeah, I like Vim. So I'm doing a little bit of Vim and Tmux and Ghosty. A little bit of Tmux and Ghosty here. All right, so now that we got our data in the right place, we're gonna go to the next phase. The next part is going to be, let me see here. Let me look at our time. Where are we? Okay, so we got a little time left, you guys. Data pipeline equals master flow chart or process. Ooh, all right. Born to do it. Data pipe, master flow chart or process. Well, if you're talking about my business, my company, we've got a pretty big data pipeline because we've got petabytes of data of JSON going through my network every day. Whoa, we have, what is it? I should know this. Well, we pipe everything into Trino, and we trigger everything through Airflow to run batch processes across Kubernetes. So we have Kubernetes workers that do this. And so whenever we do these things in batches to process like a couple of hours of data, it spins up a DAG and does a lot of calculations. I'm finding Vim harder and harder to learn with the time. Oh, really? I think that Vim is essential going to get its own operating system on a special partition or something. You think so? Well, it almost is. It's almost its own part. You can kind of think of it like that, right? A little bit. You can kind of think of it like that. Let's see here. All right. Where are we on our song here? Okay, 1 second. Let's see here. Okay, next. Bring up our next song. Okay. All right. I love Vim, you guys. I love Vim. Vim's my favorite text editor. I would always say use the text editor that makes you happy. Use your favorite text editor. The one that makes you happy, you guys. That's the one you should use. Used to do code in Vi too. Oh, it was nice and fast. It was so fast. Yeah, oh, it's so fast. I love it. Yep, I can zoom around everywhere. Everywhere. Really easy. Emacs better, sorry. Hey, hold on there. Wait a second. Emacs, yeah, I see what you're saying. I know what you're saying. You know what? I tried Emacs once, but I came from Vim. And so I was like, I want to go back to Vim. I just want to be in Vim. I don't want to deal with Lisp all day. I like my regular expressions. I like my %/ and a bunch of whatevers, right? I like that. Thank you for the hearts, you guys. Appreciate it. I like my regex over Lisp. Regex over Lisp any day. Any day for me. Regular expressions, you guys. Appreciate it. Thank you for the hearts. Thank you very much. So let's see if we can go to our next phase here. And let's make our gradient. We need to calculate our gradients. So we need to calculate our gradients, you guys. Oh yeah, that's what we got to do. Calculate our gradients. So we need to go through our prediction. Let's see, how do we want to do this? So we get our outputs, we calculate our error, and then we need to create a gradient for our weights and for a bias, right? So we got to do our weights and bias. Those are the things that we have to do. A little bit of a gradient calculation, you guys. You ready? I'm live on my app too, by the way. All right, nice. All right, let's take a little detour here, you guys. Kyle wants us to take a look over here on Discord. All right, here we go. Wait. Let's see here. Oh wait, I'm gonna create an account. Okay. Let's see if we can create an account. I already have an account. Let's sign in. Okay. Oh wait, you deleted my account, Kyle. What's the deal? Okay. Create account. Password should contain at least a symbol. Okay. I can't sign up. It's not letting me sign up. Kyle, I already found a bug. It didn't work. Sorry. It's not working. See, you meant something. You meant something else. See if it works. Generate data. Oh, sure. All right. Hey, Rox, thank you. I'm going to try it out. Let me look for your generate data. Here we go. Kyle, it broke. It's already broke. It didn't work. I don't know what the deal was. It only took us 2 seconds. What happened? Set paste. Here we go. Okay. Let's see here. Set no paste. Set no paste. There we go. All right. What is this? Shape. Shop. Okay. Is this shape? What is? Oh, samples. Here we go. Samples. Here we go. Samples? Is that what you were saying? So wait, Rox, something is going broken here. It looks weird. Dimensions, samples, 0. This can't be right. Let's see here. Full, NP full dimensions. True bias. Y equals X, true bias. All right. What do we got here? Uniform. All right. True weights. Full dimensions. True bias. Oh. We're going a step further here. Okay. Self.weight.shape. Self.weight, W-E-I-G-H-T, .shape. Yeah, that looks better. Okay. And then you got your X, and then you've got your Y. And see, it's going to be weights. In my function, it's weights. Generate data rocks. Okay, there we go. Yeah, because you already had an account, you need to create. Oh, okay. So sign in. I already have an account. Sign in. Login failed. Login failed. You shouldn't even need an account for that page. So I can't create an account, and I can't sign in. I can't do it. It's not working. Let's try it again. I'll try clicking on the link again. Oh, hey, there we go. Okay. We made progress. You'd split each quarter 4 groups and then put them into different label color tables or something like that. Born to do it. Oh, okay. You're talking to Born to do it. Oh, see. If you... Oh, hey, Dadam. Oh, I missed your message. Sorry, Dadam. Have you ever had to deal with a massive unnecessary bill from a bad approach of data pipeline? Yeah, we did. Although we dealt with it. We just paid it. So yes, Dadam, I missed your message. Thank you. Yes, good to have you here. Would you mind solving a problem for me? Thinking trading indicator like sine wave with color changes, and then Dadam. Let's see here. Sine wave. How would you identify events in AI across 0 color change amplitude? Yeah, so those are your input features, right? So you've identified your input features, and then what's your target? What are you trying to optimize for? Are you looking for future price prediction? Because then that would just be your future price prediction. So you've got your inputs and you've got your outputs. You're good to go. What else you got to do? What else you got to do? All right. You can flip, call the coin, call, flipping. What is this? The flip is unavailable right now. Try again shortly. Kyle, everything I click on says it's broken. Hey, Horizon CPU, good to see you. Welcome on in. Happy Saturday. Good to have you here. Depends on what you want to do with it. That sure does, right? That was my idea. Splitting. Oh, splitting. Got it. Perfect. All right, you guys. All right, let's see where we want to go from here. This is neat. All right, so far so good. What happens if I click on something? So I can take a look at all the pictures. Looks good. I can click the buy now button, although I do have to sign in, which I can't do. Message. I have to sign in. Okay. Share. Oh, whoa. I didn't know you could do that. Look at that. This is weird. Oh, that's neat. Kyle, I didn't know you could do that. This is new to me. What is this? How'd you do the share button here? How'd you do share? You can do it with NumPy and Python, I think. Yeah, there you go. NumPy and Python. That's what we're doing today. We're trying to get our linear regression working. Let's see, market, shop. Woo, wait. Oh, I can't click because I don't have an account. Oh, well. All right, so I guess that's one of the challenges, Kyle, is I can't do most of the things without logging in, but I already logged in and I got a different... what you doing this stream? Horizon. So we are doing Introduction to Machine Learning, and we are doing linear regression today, where we have input features and we're targeting output features, usually just one value. So we're going to predict the future. Vine Dev with the XD. All right. Ooh, trading candle or temporal search over time for an event pattern. Yeah, those are good. Those are good indicators. They're good features. You want your website to be smooth and more secure. Ooh, yeah, smooth. This is pretty smooth. It's pretty smooth. Why not do it in scikit-learn? Oh, yeah, you could do that too. You could do that in scikit-learn. We're just going more towards like the math side of things. Like scikit-learn would make it really easy. Because you just call like a support vector machine or linear regression or SVRM, right? There's just so many things that you could do automatically. And we wanted to show more of the internals of machine learning, right? So you've got your knowledge, which are your coefficients here, your weights and your bias. Then you've got your prediction function, which is going to predict the future value, right? You've got your input data, and it's going to predict the output data for those. And then we got our calculator for the loss, which is mean squared error. We're going to say how wrong the model got it based on our generated data. Our generated data here. Let's see here. Generate data. I want to see what Rocks did for us here. So let's take a look at Rocks really quick. Let's take a quick look. Do you use programmable gate arrays? FPGAs? I've not used one before. I've not FPGA. Programmable gate arrays. I've not. Don't use autofill password and you should be able to create an account. All right, Kyle, this is the last. I'll try it one more time. All right, so sign up for free. Here we go. Create account. Let's see. Okay. Create account. Nope. Oh, wait, did that work? Okay. So it sent me an email. Oop, whoa, I can't. Hold on a second. It's gonna take me a second, you guys. Let me see here. This is all right. I got the sign in email. All right, confirm my email. Confirmed. All right, I'm signed in. All right, that was great. Kyle, very nice. Thank you. Okay, now we're signed in.
Hey everyone, this is the striped shirt version of the Caroline articulated figure from the movie Caroline. Hey everyone, this is the striped shirt version
this is
of
great.
the Caroline articulated
So here we go. It basically does everything that you'd think it should do. So by starting. What is this starting? Oh, here we go. Okay. Connecting to your Stripe payment rails. Nice. All right. And then I could purchase it. Although, because shipping is $4.99. Okay. Still depends on what you wanted to see here. Is it just a hobbyist project or something more important? Yeah. Okay. Let's see if we can see. Kyle, this is great. It looks good. It looks like you got it working. I'm curious to see what your users will say. Hey, Lord of the Rings. Is that VHS? That looks like VHS. No way, that's OG. Or are these books? No, these are books, aren't they? Whoops, I got that wrong. I got that really wrong. Hey, look, it's the, oh wait, no, it's an older media. All right. So, hey, Rox, I'm gonna try out your function here. Let's see what this looks like. Generate data. There we go. Try that out. Run. Okay. Features and targets. It looks like it did the same thing. 1. Here we go. Let's try again. Features, targets. Yeah, looks good to me. Did I do that right? So wait, this you can do, this works fine. I guess you could do it this way too. X and Y. Yeah, that looks good. That's fine. All right, Rox, thank you very much. Appreciate it. Go live on Flip. So what's the button to do that? Create, go live. All right. Wait, no, whoa. I can't show that. One quick step. Buying, okay. There we go. Allow. Okay. All right, is it working? Can you guys hear me? Is it there? Did we do it? Success. Kyle, we did it. Check that out. Oh, what do you know? That's really unexpected. You did it, Kyle. Are there some, oh, there's a chat too. Hello. Yo. Hey, Kyle, that's great. Hey, how's it going there, Mahindra? Good to see you. Mohinder. Good to see you. Welcome on in. Happy Saturday. Good to have you here. Kyle, this is cool. You did a good job. Look at that. So, is that running on someone's Raspberry or local? I don't know. It's wherever Kyle put it. Like on a desktop. It could be. Let's see here. All right. Kyle, this is great. Thank you for the party poppers, you guys. All right. Okay. Very nice, Kyle. All right. Messages. List an item. Oh, neat. Okay. Title required. All right. Test. I set a price. Okay. 1. I can't save a draft if I don't have a test photo. Okay. So, I mean, that's not a bug, but, you know, it is. I would like to be able to save a draft. Although I don't want to do any data input. I don't want to do any data input. That's one of my feedbacks. I prefer you perfected multiple messages to multiple people now. Oh, retro. Nice. Very nice. Cal, this is great. Good job. As far as I can tell, it did the trick. I would test it further, but then that would be doxing myself because I have to do extra stuff. Okay. So now I think what we should do is we should probably plan on finishing linear regression maybe tomorrow. I think that might be a good idea. So we can finish linear regression tomorrow. Let's see here. We're very close. So we've got our loss function, we've got our data generation function, we've got our predict function, we've got our initial weights and biases. Let's see here. Okay. I would like to see if we can go just a smidge further and see if we can calculate the, so we got our features. Let's see here. Oh, see, that's what I thought. Okay, sample, batch, and features. Okay, so it's batch and features. And then, oh, interesting. Oh, right, okay. Okay. So we can do, we need to define a train function, basically, is what we got to do next. Okay. Def train. Self. And then we can have our features and targets, right? So we say features, targets. go. Make sure it still runs. Okay, looks good. Cool. Excellent. Stephen, create enterprise bus to use subscribe publish for 1 to N consumption. Yeah, born to do it. Wait. What are you saying over there? Born to do it. Create enterprise bus to use subscribe publish for 1 to N consumption. That's basically what my company is. That's what I did. Yeah, you got it right here, you guys. This is what my company is. We provide publish subscribe communication for 1 to N consumption. I mean, that's a good way to say it. Quality of service program, telemetry, radiology. Thank you for the party poppers, you guys. Interactive programming, running simulations. Oh, you guys are talking about something else over there. All right, no worries. Okay. Hey, can you show a quick demo of PubNub simple use case chat? Yes, I think to create a web chat feature for one of my experiments. That would be great. Absolutely. That's what PubNub does. I know, right? That's what PubNub does. Sure. All right, so let's see here real quick. There is some tutorials. Let's see if we can grab a tutorial here. Or tour. I like the tour better. The tour is going to be easier to see. So click on JavaScript. Then it's going to ask you to subscribe to a channel. We're going to subscribe to my channel. You click subscribe. This is the code to subscribe to the channel. Great. That's step 1. Step 2 is we're going to send messages to those channels, right? So you say pubnum.publish. So you subscribe and publish. Really simple, really straightforward. So we're going to say, hello, rocks. Right there, right? And then I click publish, and the message is received on any computer in the world that has called the subscribe function. Right there. Really easy. And then you can change the code to say, how are you? ? Publish, right? So you can see the output there. And then you could say, oh, great. Oh, great. That sounds good, right? Publish. So simple, publish and subscribe. Rocks. Easy, super clean. I didn't see you live on my app, but I think I was delayed on YouTube. Oh, got it. Yeah. I think we were there for a good 2 to 3 minutes. You're talking about Octave. Oh, got it. Okay. Sorry. My lucky guess, Steven. Hey, you did it. You did it. All right. So did that make sense, Rocks? Let me know. I can send another message. Here we go. Another message. There we go. Right. Let me click send, publish. Boom. Right there. All right there. That looks easy. All right. I know. It's pretty good. That's a good starting point, you guys. It's a pretty good starting point. Thank you for the party poppers and reactions, you guys. Appreciate you. Thank you so much. Good to have you here. Good to have you here. So the first thing you need to do is you need to get your outputs from your prediction. So self.predict, and you need to predict your features, your inputs, right? Predict, and you're going to get your outputs. Or predictions, right? Predictions. So that's step 1 of train. Step 2 is you need to calculate the loss. So loss equals self.loss. And you type in your predictions and your targets. Predictions and targets. Like that. And then we're going to print the loss. See where we're at here. Let's see. Let's run our train function really quick. Train. Self.train. There we go. See what that looks like. Print that out. Model.train. Whoops. 1 second. Model.train. Here we go. Oh, it takes a parameter. It needs input data. Right. It needs input data. So let's say features. Try that. Okay. Train missing 1 required positional argument targets. Oh, right. Okay. There we go. Okay. 15. Look at that. Okay. So this is our loss calculation. And what we need to do is we need to correct that now. We need to calculate our gradients. So I think that would be a good thing. Hey, Krishna. Hello, man. What's up, man? Good to see you, Krishna. Good to have you here. Happy Saturday. Stephen, long time. Oh, Quantified Quantum. Hey, welcome on in. Good to see ya. How are we doing? We're doing fantastic. Thank you for asking. Good to have you here. Have you got a good weekend so far? Good weekend so far? You subscribed to Stephen. Oh, thank you, bro. Born to do it. Thank you. Waiting for his publish. Oh, you did. You subscribed to Stephen Blum on this? Wait, what do you mean? Hey, Sergio, thanks for saying hi. You're saying, oh, you're probably not talking about this. You're probably not. You're probably talking about YouTube, maybe? Born to do it. All right. Now we need to do our gradient calculation, which we might save for tomorrow, but we'll keep, YouTube, yes. Oh, there we go. Born to do it. All right. Good to hear. Thank you. Thank you for your subscription. Appreciate it. That was very nice. He was saying publish, subscribe. Yeah, he was. Yeah. I'm like, hey, that's what I do. All right, you guys. So do the coin flip when you get a second now that you're logged in. All right, I'll try it. I tried it before. It didn't work. Let's go back. All right, here we go. So there was a coin flip around here somewhere. Where did we do that at? Where was the coin flip at? Was it around here? No, I remember seeing it before. Create? No. Messages. Next to marketplace. Marketplace. Oh, here. Oh, right there. Okay. Call F. Okay. Oh. Call the coin, 1 free flip a day, flip the meter for a guaranteed fee-free order. Hey, CPT Package, thank you for subscribing. Welcome on in. Good to have you here. Happy Saturday. We're doing software engineering. Right now, though, we're looking at Kyle's app. Use my next order. Armed, it'll apply to your next checkout. Oh, very nice. We'll waive 50% of your flip-flop fee on your next order within 2 to 3 hours. All right. Before it expires, within 2 hours and 3 minutes. Did the animation not work? No, it didn't work. It did not work. So I guess we found a bug. We found a bug. Found a bug right there. Arc devs are active today. They added a few updates today in Pac-Man. Weird. Wait, Retro, really? Really? I don't know about that. Kyle, this is great. Thank you. Can I flip again? I've already flipped and armed. Nice. Kyle, that's awesome. Cool, Kyle. Okay, let's see here. It needs to be hidden to user who are not logged in. Yeah, that makes sense. That makes sense. Okay, so how do we calculate our gradient? So we've got our loss and we need to optimize, right? So we can do our gradient calculation. Def gradients. Calculate our gradients, right? Just a smidgen of gradient calculation. Gradients. Interesting. Okay. And then we can do, so we'll fill this. This is what we'll probably do next time. This is what we'll do. We'll fill this out so that we're we'll get this ready for next time. Self. And then we need our loss. Let's see. We need our loss. And then we need our outputs. We need everything. We need our predictions. We need a lot of stuff. Weights and bias. So we've got those. We need our X. And then do we have our loss? We've got our loss there. So gradients.loss. And what else do we need? Do we need the predict? Nah, we need the predictions. Predictions. I think. Okay, so we'll get this ready for tomorrow. We're gradients and then our optimizer. Def optimize. And then we need our gradients. Okay, so this is what we'll do tomorrow. Hi, brother, can you teach me? Hey, yeah, absolutely. Aravinda. Hey, Aravinda, good to have you here. What do you want to learn? Stephen, why are you not using AI to drive your development, e.g. plan features and coding approach? Oh, well, I kind of am. So I've got my notes on the side of my screen, and I'm walking through and building it slightly differently. So I'm building it the way I would like to build it. So this is why I'm trying to fit it into the right spot. For example, bro, what you doing? Can you brief, please? Sure, yeah, absolutely. So we're doing Introduction to Machine Learning. Well, over the past few days, we have finished a few lessons. We've created some tensors. We did some math against the tensor, so you know how to manipulate tensors. We did indexing and slicing, so you can get data out of your tensors. We did aggregations, so you can sum and minimize, maximize your tensors, get the argmax to find the value of the index of the max value. The linear algebra with some dot product, really straightforward and easy. And now we're doing linear regression. We're currently right here. That's what we're doing right now. Good to guys have you here. Though we do got to get going. I had a lot of fun. Nice, yeah. So this is what we did last stream, and today we were doing linear regression. We started by building our own model in a linear regression class here. So you can see we got our weights and biases. We generated some test data that's going to sample, that's compatible with the dimensions of our weights and biases. And then we are going to create a train function that's going to call our gradients and optimizer. We currently don't have those implemented, but I believe that would be a really good topic for tomorrow. So we can get these correct. We want to get these correct for you guys. So the good news is we've got a good initial model that's running. The only thing we need to do now is the regression part, right? We got to do the regression part. Sorry for not letting you lock in and distracting you. Hey, it wasn't even worth it. Hey, don't worry, Kyle. It was great. I had fun checking out what you've been building over there. It looks really good. It looks like a full easier eBay, basically. It looks like an easier eBay. And it's live in real time. And so it's got like even nicer features. So I think that's pretty great. Is this an introduction over the last 2 weeks of videos? I'm interested. Yeah, so over the last 2 videos so far, we've done the very basics, by creating tensors and manipulating tensors. So that's the last 2 streams. And the next few streams, we will focus on linear regression, which is going to be kind of the pinnacle of what we need to do for machine learning. There are a few other things that we could also cover, like a lot of topics in here, and I would love to continue down this path. And we will do that. In future streams, we've got a few other topics that will interrupt the introduction course. So we are planning on building a YouTube clone with targeting specific tech content. So we will do that. That'll be fun. That'll be a couple weeks. And then we also want to learn some other languages. That'll be a lot of fun. And we have a guest speaker on Monday. We've got a guest speaker on Monday. Bro, your eyes look kind of red. Are you okay? I'm good. We're good. Are they red? Wait, hold on. Let me zoom in on that. Zoom in. They're good. Yo, they're good. We're good. You have a beautiful day, everyone. See you, Sergio. Thank you. All right. I had to change your login stuff. It had to be all gated. Hey, that's a recent change. All right, no worries, Kyle. What's the latest hot topic on machine learning? All right, bye, everyone. GCA, thank you. Yeah, we're wrapping up, you guys. I gotta go. I gotta take care of, chores and things like that. Born to do it. The hottest topic right now would probably be the Mamba, I think. The Mamba, right? The Mamba model, which is the newest large language model approach. Cool. Thank you, guys. All right. Have a good rest of your day. Bye, everybody. See you guys tomorrow. Enjoy the rest of your Saturday. See you guys. Bye, everybody.